Afternoon and welcome back to Dr. Logic Awkwardly Does Logic. We've talked about the language of modal propositional logic, so now let's talk about what things mean in this language. The intuitive notion that we were motivating a couple videos ago is that when we're talking about necessity and possibility, we're not just talking about what is actually true at this world, but ways in which things could have been true. So all of the possibilities, all of the different situations, all of the different times, all of the different knowledge contexts. What we will see is that modal logic is able to account for a huge variety of different types of necessity just by saying a little bit about kind of what these possibilities are. But we don't have to say specifically what these possibilities are in order to be able to do the logic. Logic doesn't require us to be talking about this type of possibility versus this other type of possibility. That's part of why logic is so useful. So if we want to come up with a kind of generic sort of notion of necessity and possibility in a generic framework that will be applicable to many different accounts, how would we want to do that? We're going to take this base notion of alternate things. We'll call them worlds. Alternate possible worlds is the kind of technical phrase that we use. And the idea is that things are the way they are in our world, but they could have been otherwise, or at least some things could have been otherwise. Some things couldn't have been. So let us get up our whiteboard. And what we have is, here's our world. We'll call it W. But there's all sorts of kind of ways in which we can vary facts about the world. So maybe today I happen to be wearing green, but I could have been wearing red. And maybe over here, this is the world in which I am wearing something red. Let's call that W prime. Or maybe there's a world in which I'm wearing black, and that's W2 prime, and so on and so forth. These are all of our possibilities. But in a given context, when we're talking about whether something is possible or not, we want to be able to sometimes restrict essentially which of these alternatives are relevant. So maybe we've got the world where I'm wearing something green, the world where I'm wearing something red, the world where I'm wearing something black, and the world where I'm wearing something orange, I don't know. But suppose that in actuality, I only have a wardrobe that has green and black. So this world is in a sense relevant to determining what's possible. And this world, none of the other options are in a sense live, because given how my wardrobe is, I couldn't have been wearing orange because I don't own anything orange. Take it just as a toy example. Or consider a sort of situation where you've got temporal progression. So this is now, and then there's all sorts of like time points in the future that we might potentially visit, but there's also a limit to like how fast we can travel, and that limit is going to be the speed of light. This means that anything else that's kind of over here, which is outside of what is called the future light cone of now, all of these little worlds or times or situations or whatever you want to think of them, they aren't accessible to us. No way, there's no speed that we could travel at that would actually get us over into kind of like this part of the universe. So they are not relevant. It's only going to be these inside this little cone-like situation that are. So this is the intuitive idea behind our basic semantic notion, which is a Kripke frame. So a Kripke frame, named for Saul Kripke, who is the first to articulate this approach to modal semantics in a mathematically rigorous way that allowed him to prove some very nice soundness and completeness results, things we'll be talking about in future videos. So a Kripke frame is just a pair, and we will use this kind of fancy calligraphic F to represent it. And it's an ordered pair. We always write the W first and the R second, where, yeah, can't write W's. There we go. W is a set. And it doesn't really matter what goes into this set, but we're going to call these things possible worlds, and we'll refer to them with W, W prime, W2 prime. If we need more, we might have W1, W2, W3, and sometimes we even have X, Y, Z, etc. World-like letters towards the end of the alphabet. And then R is a binary relation on W. So this is to be understood as the accessibility relation. Which possibilities are the live or relevant possibilities from the point of view of a given world? So if you like kind of mathematical or functional notation, then we can make this explicit. What R is just going to be a subset of the Cartesian product of the set of worlds. So it's a set of ordered pairs. So if W prime is in this relation, what we can do is say that W prime is accessible from W, or that W prime is relevant to W, or even that W sees W prime. So this seeing language is something that we will use quite a bit. And the nice part about these Kripke frames is that they are really easy to represent in diagrammatic format. So we've got our set of possible worlds. They look something like the drawings I was drawing just before I cleared my board. And W, W1, W2, W3, 4, or 9, 5, 6. And then if we want to represent the accessibility relation, all that we need to do is draw an arrow from the one world to the next. So if W sees W prime, so this is just another way of representing this idea that the pair W prime is in this binary relation, then we draw an arrow from W to W prime. And these arrows can be any way that we want. So maybe 1 sees 5, and 1 also sees 3, and maybe 3 sees 2, and 2 sees itself, and 2 also sees plain old W. Maybe 6 doesn't see anything at all, but 9 sees that, and 5 also sees 9. There is at this point no constraint. So at the very base level of introducing our kind of framework for semantics for the meaning of modal propositions, we don't have any constraints as to which worlds are going to be accessible from other worlds. This is something that will come later on when we want to be able to capture particular types of modality. But at this point, we just want to know kind of base minimal conditions. What do we need to build in order to be able to say something about when a proposition that involving modal operators is true or false? So we'll look at that next time. We will build on this notion of Kripke frame. We'll build Kripke models based on these frames, and that will allow us to start talking about the truth and falsity of modal propositions. So join me then. Hope to see you again. Cheers.